Hello everybody, today we're going to be learning about ionic equations. So ionic equations are going to be double replacement reactions. So you are given lithium sulfate, which is aqueous, that's what the AQ is, plus silver nitrate, which is also AQ, which is aqueous. So we're going to write down our formula, remembering our charges. Sulfate is a polyatomic ion, which is -2, so that's why we have two lithiums, because they're an alkali metal, so they have a -1 charge, plus silver nitrate. We know silver always has a charge of 1. NO3 is a polyatomic ion, which is -1. We're going to do double replacement, so we're going to have to balance it because we have two lithiums here. To do double replacement, A is going to go with D, and then B and C are going to go together. So if there's two lithiums, and lithium has a charge of +1, and there's two of them, and nitrate has a charge of -1, and there's only one of them, we're going to have to balance that. So we're going to put a 2 on that whole equation, because these two are bonded together, so we have to multiply the whole equation by 2. Then we're going to get 2 LiNO3, which is going to be aqueous. And then sulfate has a charge of -2, and we have two silvers that balanced out good, plus Ag2SO4. Now I put a subscript 2 here because if I were to put a coefficient 2, it would multiply this sulfate by 2. And sulfate already has a charge of -2, so we don't want to do that. That's why we use a subscript. Now, that is our molecular equation. That's the first step of this problem. Our next step is going to be the complete or total ionic equation. So to do that, we have to split apart the aqueous solutions, and we leave the solid precipitate alone. You should have an activity series and look up silver sulfate. That should be S, which is a solid or precipitate. So since lithium sulfate, which is aqueous, and silver nitrate is aqueous, we're going to split those apart. So Li plus, because we have to list the charges, SO4, 2 minus, plus 2 Ag plus 2 NO3 minus, yields or produces, that's what that arrow means, 2 Li, we split that apart because lithium nitrate's aqueous, and since this is a precipitate, we're not going to do anything with it. Okay, so that is our complete or total ionic equation. Now we're going to do our net ionic equation, which we have to cancel out the spectator ions. The spectator ions are the same on both sides of the equation. So we have a 2 Li plus here, and over here we have a 2 Li plus. So those are going to cancel out. And then we have Ag, that's not the same, so we're going to leave that. SO4, that's different, so we're going to leave that. NO3 cancels out, we're going to leave that. So now our net ionic is going to be whatever we have left over. So it's SO4, 2 minus, plus 2 Ag plus Ag2SO4, which is a solid. And that is how you do ionic equations. There's another type which ends up being a water. So an example of that is hydrochloric acid, which is aqueous, plus barium hydroxide. Hydroxide is a polyatomic ion, which is -1, so we're going to need 2 because barium is an alkaline earth metal, so that's going to be a 2+. And now we have to do double replacement on this. So A is going to go with D, and then C is going to go with BA. So we're going to do that right now. HOH is just water. Now there's a problem with this. Barium is a 2+, and chlorine is a -1. So we're going to need to balance that by putting a 2 there, and we're going to have to put a 2 here, and that means we're going to have to put a 2 here. Because if we multiply the chlorine by 2, we have to do the hydrogen by 2, which means we're going to have 2 hydrogens, 4 hydrogens, so it's going to be 2H2O, because we have 2 hydrogens, and 2 oxygens. So we're going to have 4 hydrogens and 2 oxygens. Now, we've learned that this water is a liquid, so it's not going to break apart. Barium chlorine's aqueous. Now we're going to break these apart. 2H plus 2Cl minus, plus Ba2 plus 2OH minus yields Ba2 plus 2Cl minus plus 2H2O. Now, we just did our total ionic equation. So now we're going to do our net ionic equation. H, different over here. Chlorine, that's the same, so we're going to cancel that out. Barium is the same, so we're going to cancel that out. Hydroxide and hydrogen are different, so we're going to leave those. Now, we end up with 2H plus 2OH minus yields 2H2O. Now, this problem's a little tricky because you have to divide by 2 or simplify to the clearest whole number ratio. So that's going to be H plus OH minus yields H2O. And that is how you do ionic equations.